All right, today we are diving into a really cool new AI framework called AgentFly. And the big idea here is how it's trying to solve one of the trickiest problems in AI, teaching it to learn from its mistakes without, performing the equivalent of digital brain surgery. So let's frame this with the big question right up front. How do you get an AI to learn from all its new experiences, the good, the bad, all of it, without having to go through this super expensive, incredibly complex process of retraining the entire model from scratch? That's the nut that researchers are really trying to crack. And to really get why AgentFly is such a big deal, you first have to understand the dilemma that pretty much every AI agent is facing right now. They're kind of stuck between a rock and a hard place. I mean, think about it. The AI agents we have today are incredibly powerful, but they're also weirdly static. Once they're out in the wild, they don't really learn on the job. So when they bump into a totally new problem, they're faced with a choice, and neither option is very good. And here are those two flawed choices. On one side, you've got these fixed, rigid workflows. They're great for a single, specific task, but the second you throw them a curveball, they just completely break. On the other side, you have that brain surgery, or LLM fine-tuning. Sure, it lets the AI learn, but it's just brutally expensive and inefficient. You need a mountain of data and computing power, which makes learning on the fly basically impossible. So how do you break out of that trap? Well, the researchers behind AgentFly looked to a pretty fantastic model for learning and adapting: us, the human brain. And this quote from their paper just nails the core idea. It's so elegant. They're saying, stop trying to constantly rewrite the AI's core programming. Instead, just give it a memory. Give it a place to store all of its past experiences, what worked, what didn't, so it can look back and make smarter choices next time. Now, this whole approach actually has a name. It's called case-based reasoning, or CBR. It's a classic idea in AI, and it's all about solving a new problem by remembering a similar one you solved in the past, and then just tweaking that old solution. It's basically learning by analogy. And really, it's just a fancy term for something we all do 100 times a day, right? You're facing a tough problem, and you get that little spark of recognition. You think, wait a second, this feels familiar. This is just like that time and boom, you're using a past experience to navigate the present. That's all this is. Okay, so the theory is cool, but how does this actually work? Let's peel back the layers and see how AgentFly actually implements this memory system to learn. The whole system is basically split in two: a planner and an executor. Here's how it goes down. First, the planner, which is a big, smart model like GPT-4, gets a task. But before it does anything, it immediately checks its memory, this case bank, for anything similar. Based on what it finds, it creates a new plan. Then, the executor, a smaller, nimbler model, takes that plan and actually does the work using tools. And finally, this is the most important part, the result of that whole process gets saved right back into the memory for next time. And that's the magic loop right there. Plan, act, and remember. It's a simple feedback cycle, but it means that with every single task, AgentFly gets a little smarter, its memory gets a little richer, and it gets better at solving the next problem, all without ever having to do that costly brain surgery. Okay, that all sounds great on paper, doesn't it? But the real question is, does giving an AI a memory actually work when the rubber meets the road? Well, the researchers put it through the ringer on some seriously tough challenges to find out. Let's just start with this one number, 87.88%. That's the score AgentFly got on the GAIA benchmark, which is this notoriously difficult test for AI agents. This score put it right at the top of the public leaderboard. But that number is even more impressive when you see the competition. AgentFly didn't just win, it blew past the other top AI frameworks. I mean, look at that gap. It cleared some really strong competitors by more than 10 percentage points. That's a huge deal, and it really shows this memory approach is onto something. But this to me is the real mind blower. See, the true test of learning isn't just solving problems you've seen before, it's about tackling something brand new. So they tested AgentFly on tasks it had never been trained on. And look at these performance boosts, almost a 10% jump on one data set. This is proof that it's not just memorizing answers, it's actually generalizing from its experience to become a better all-around problem solver. So what does all this add up to? Let's zoom out and think about what this means for the bigger picture, for the future of how we build AI that can actually learn. So why is this so important? Well, it boils down to 4 huge things. First, efficiency. we're talking about a way to make AI learning so much cheaper and faster. Second, scalability. Now, agents can actually learn in real time as they go. Third, generalization. As we just saw, this helps AI solve totally new problems. And when you put all of that together, you're looking at a major step towards that huge ultimate goal of artificial general intelligence. AIs that can adapt and learn just like we do.
So I'll just leave you with this final thought. We're on the edge of a shift from AI that's static to AI that's dynamic and constantly learning. So what happens when every AI agent out there can learn from every single thing it does instantly and remember it forever? Just think about the possibilities. They are absolutely staggering.